Welcome to Math 101. Today we're going to talk about how we can use Venn diagrams to organize information to help us solve problems. Now, you may have used Venn diagrams in the past. Oftentimes they're used to compare and contrast two things. So you might have, if you wanted to compare and contrast, say, a lemon and a banana. Okay. They're both of them are fruits, right? So that's one attribute of both of them. They're both fruits. They're both yellow, right? They're both yellow. A lemon, though, as far as its taste, is sour, whereas a banana is sweet, right? So those are kind of the attributes for a lemon and a banana. Okay. Now, if you wanted to organize that in a Venn diagram, you would use, circles to represent the set of attributes, set of all the attributes of, say, a lemon. Okay, so say that circle represents the attributes of a lemon. And another circle would represent the attributes of a banana. Okay. And some of their attributes are different and some of them are the same. And the ones that are the same, we can write in the intersection of these two. So both a lemon and a banana are fruits, right? So we could write fruit in the intersection, right? Because that's an attribute of both the lemon and the banana. They're both yellow as well, right? So I can also put yellow in the intersection, right? Now, a lemon is sour and a banana is sweet. Now, sour is unique to the lemon and sweet is unique to the banana. So it's in the set of so sweet is in the set of attributes for the banana, but not in the set of attributes for the lemon. In the same way with sour, sour is an attribute of the lemon, but not an attribute of the banana. So that's generally how you may have encountered Venn diagrams in the past, just for organizing information. We're gonna look at this first example here, and it's basically based off of the actual set of information I have for our class. We have 29 students enrolled in the class as of the end of August, last time I checked. It may have changed by the time you watch this video, but we currently have 29 students enrolled in this class. 19 are freshmen and 16 are business majors. Okay, so those are some attributes of the students in our class, right? Some are freshmen, some are not. Some are business majors, some are not. Okay, and we're told that there are five students who are neither freshmen nor business majors. Okay, and then we're asked some questions about what can we figure out from this class? Like how many students are enrolled? How many students enrolled in this class are freshmen or business majors? Okay, so freshmen or business major, either a freshman or a business major or both. How many students enrolled in this class are freshmen and business majors? Okay, so but how many have both of those attributes? How many students enrolled in this class are freshmen and not business majors? Okay, so we're asked a bunch of questions about, given the information we have, can we figure out these the answers to these other questions? Now, one thing that I could do is I could take all the people in this class and put their names in a Venn diagram, like I did with the lemon and the banana. Okay, which I did. And we could just count, if I could, this was kind of a lot of work to go through and figure out, okay, who's a freshman but not a business major, who's a business major and not a freshman, who are the freshman business majors. Okay, that's in the intersection here. And then there are some students who are they're neither freshmen nor business majors. Okay, so this is me putting all the information into a Venn diagram, looking at each person's name, looking at whether they're a freshman or not, looking at whether they're a business major or not, and just putting their names in the diagram. Now, I would, a lot of times we're dealing with, in this class we're only dealing with 29 students, so it's fairly manageable, but a lot of times we're dealing with large amounts of information and we don't really care about the individual names, we just kind of want to know quantities. So let's go back to up to our problem. I could go through this Venn diagram and I could just count and figure out the answers to my questions. But so let's see if we can use a Venn diagram without knowing the names and see if we can figure out these questions. Okay. So, okay, I have a little bit of a problem because my screen is not big enough to hold the whole page here. So, but let's draw a Venn diagram. Okay, so let's say that this is the set of all the freshmen. Okay, so I'm going to call this set F. Okay, F is the freshmen in the class. Okay, and I can draw another circle to represent the business majors. So B, I'll call that set B, business majors. I'll just call it business. Okay, so there's the two types of students in our class. Now we also have some students that are outside of these two circles, right? They're not freshmen, they're not business majors. They might be a junior in psychology, or we have a number of other students. So I'm also going to draw a box around the whole thing to represent the set of all students in the class. Okay, so all of the students in this class will fit into this box in one way or another. And I know that there's 29 of them, right? So I'm going to write 29. And I'm going to write it on the line because it's not, if I write 29 here, I tend to think, okay, that's 29 people who are outside of these two circles, but it's not. It's 29 is actually the number of people who are in the whole class, including the people that are in the circles. So I like to, when I have that sort of a number where it's just the total amount, I kind of write it on the line. I don't know how to divide it up yet. I don't know how to divide it up between the freshmen, the business majors, and those that are neither. So what else are we told? We're told that there were 19 freshmen. Okay, so 19. I'm going to put 19. I'm going to, again, write it on the line because I know that the whole set of 19 freshmen or 19 students are in this freshman circle, but I don't know. Some of them are business majors and some are not. And I don't know yet how to divide it up between these two regions. So I'm just going to write the 19 on the line. Let's see, we're told there's 16 business majors. So again, I don't know how, some of them are freshmen, some of them are not. So I'm going to just write it on the line. And then we're also told that 5 are neither freshmen nor business majors. Okay, so they are outside the freshman circle and outside the business major circle. So I'm going to write it out here in this white space that's outside the circles, but still inside the class because they're part of our class. Okay, that's all we're given, really. So now we have to try to figure out the first question, which is how many students enrolled in this class are freshmen or business majors. Okay, the or is a big important thing. You can see that in the notes it's bold. And so you qualify as a freshman or a business major if you have either one of those attributes. If you're either a freshman or a business major, or you could be both. So what we're asking is how many students are inside these two circles, the freshman or the business majors circles. Okay, now some of them may be freshmen and not business majors. Some of them may be business majors, not freshmen, and some of them may be both. So let's see if we can figure that out. Well, so how can we figure that out? We know that there are 29 students, and 5 of them are not inside the two circles. So basically, what we can do is just take the 29 and subtract 5. And that's telling us then, if you're not outside the two circles, you must be inside the two circles. So that's telling us we have 24 students that are freshmen or business majors. So they're somewhere inside the two circles. So I'm going to go back up here to my to the question. I'm going to say 24 students. So 24 students are either freshmen or business majors or both. Okay, so that just means they're inside one of the two circles. All right, so next question is how many students enrolled in this class are freshmen and business majors? Okay, so now we have the word and, which means that you have to, in order to qualify for this particular You know, if I was gonna ask you to stand up, if you're a freshman and a business major, you would have to have both of those attributes. All right, so what we're looking for is the intersection of those two circles. But how do we figure that out? Well, one thing you can look at, you can see we have 19 freshmen and 16 business majors. Okay, if we add those up, let's just add those up. 19 and 16. All right, so what is that? 35? That's 35 people. But wait a minute, there's only 24 inside those two circles, right? So where are the extra coming from? We have basically 11 extra. You know, if we look at the difference between what's supposed to be inside those two circles, 24, and how many we get by adding up the numbers in, you know, the number of freshmen and the number of business majors. The problem is that we're double counting these people in the intersection, right? These people that are both freshmen and business majors, they end up getting counted twice because they get counted in the freshman count and they get counted in the business major count. Okay, now the difference between these two, if I take 35 minus 24, what is that? That's 11. So we have 11 people that have been overcounted. They've been double counted. So that must be the number in the intersection. All right, so that's the answer to our next question, is that there are 11 students that are both freshmen and business majors. All right, so the next question asks, how many students enrolled in this class are freshmen and not business majors? Okay, so now we're looking for these people who are outside the business major circle, but they're inside the freshman circle. All right, so your name would go here if you are a freshman, but not a business major. Well, we know that there are 19 total students who are freshmen, and 11 of them are already counted because we know that they're business majors. So that just leaves 8 left that have to be freshmen and not business majors, because these two numbers have to add up. The numbers inside the freshman circle have to add up to 19. Okay, so the answer to question C, we can just take 19 minus 11 that we know are business majors, and that gives us 8 freshmen. I'll just write students, but because I'm answering this question, but they're 8 students who are freshmen and not business majors. All right, so the last question is just asks, how many students enrolled in this class are business majors and not freshmen? All right, so if you're a business major and you're not a freshman, you're inside the business major circle, but you're outside the freshman circle. So that means you're in this white space here. Now we know there are 16 students who are business majors. 11 of them are also freshmen, so there has to be 5 students who are business majors but not freshmen. Okay, so I'm just going to write 5 students. All right, so there we have used a Venn diagram to help us organize the information we're given in the problem, and then figure out more information. So, and a Venn diagram is just basically a visual representation of the relationship among things. Okay, so you can look ahead at the next. There's 3 more examples to try with just these Venn diagrams with 2 categories. Just some practice problems to try. You can go ahead and look ahead at those, and I'll meet you in the next video.